All right, welcome to Applications Part 2. And these are basically what we call speed, distance, time kind of questions. And they generally have to do with a river. Now, you've already seen this fine artwork here, and you're thinking, hey, that's a river. And I gave the information that the current of the river is in this direction, and it's 8 kilometers per hour. Now, before we start an example, I just want to make sure we're clear on one thing. Let's say we had a little boat here. Okay, and let's say our boat, when we run the little motor, we can do, 15 kilometers per hour. And that would be in still water. You know, there's no current, there's no wind. We're just zipping along, the motor pushes at 15 kilometers per hour. So suppose you are now sailing on the river, you're going back and forth. If you're going with the current, that means it's your boat speed plus the 8 kilometers per hour that the current is pushing. So your speed would be 23 kilometers per hour. Okay, so that's if you're going with the current. But if you turn around and you're going against the current, okay, that means your 15 kilometers per hour is slowed by 8 kilometers per hour, leaving you with a kind of a net push of 7 kilometers per hour. So I just wanted to make sure we're clear on the idea that if the boat's going this way and you're going with the current, you're zipping pretty fast, 23 kilometers per hour. But if you turn around and you're heading this way, okay, so the little boat goes this way now, then it's going a lot slower, and that's because you're going against the current. Okay, so what we're now going to do is give you an actual example and tell you what we know and what we don't know. Okay, so we're sailing on a river, and so here's our question. Okay, the current in this particular river is 6 kilometers per hour. Okay, and then what we did is we're going to be traveling with the current, so when we go with the current, we went a total of 102 kilometers. Zipping along, and we went quite a distance, actually. And then we turn around. Now we're going against the current. And I don't know if we ran out of gas or what, but we only covered 44 kilometers, so we didn't get back to our starting point, but that's okay. You know, we maybe stopped and called it a day and called for people to come pick us up or something. I don't know. But anyway, that's the scoop. And there's one other thing. The total time that we've been boating is 5 hours. Okay, so we've been 5 hours out on the water. And so here comes the question now. What's the boat's speed? What's the boat's speed? And we mean in still water. When we say the boat's speed, that implies without the effect of the current. Okay? So whenever you have a speed, distance, time question like this one, my suggestion is that you take a little table and you fill it in. So speed, distance, and time. And what we're going to do is we're going to fill all that in. And there's sort of two categories here. There is with the current, and then there is against the current. Okay. So let's see here. What do we know about the speed with the current? Well, we don't know the boat speed, so I'm going to call that x. But I do know it would be x plus 6, because you're going with the current. And if we turn around, it would be x minus 6. All right. Now, the other thing is, what about distance? Well, when we went with the current, we traveled 102 kilometers. When we turned around, we were only able to go 44 kilometers. Now, what about time? Well, there's not much I can do about time other than I know that the total is 5 hours. But what can I do for these individual expressions here? Well, here's how we do this. There's a little triangle you might have learned in science, which is velocity is equal to distance over time. So this little relationship here is how we're going to get an expression for time. In other words, time is equal to distance divided divided by velocity or speed. So in other words, here's what I'm going to use. Distance divided by speed, in this case, is equal to the time. So when I go with the current, my time is 102 divided by x plus 6. And when I go against the current, my time is 44 divided by x minus 6. Well, here comes my equation. I can now set up the time that I'm going with the current. Okay, so 102 divided by x plus 6. I'm going to add to that the time when I go against the current. And that's going to equal my total time of 5. So now I've got my equation. Now I can go ahead and solve it. So I'm going to clear off the top of this page here. I don't want to clear the whole thing because I like my equation at the bottom there. So let's just make some room here. And now we can get back to work. So in order to continue to solve this, I am going to multiply every term by x plus 6 and x minus 6. All right, so my first term, the x plus 6's, would cancel, and I'm left with 102 times the x minus 6. So 102 times the x minus 6. Then it says plus. Then the x minus 6's cancel, and I have 44 times the x plus 6. And that's going to equal 5 times x plus 6 times x minus 6. Nothing cancels. So to help me, I'm actually going to FOIL out or expand out the brackets a little bit here. That would be x squared. Then I would get negative 6x and positive 6x, which cancels. So then I just have minus 36. Okay, so that looks pretty good. Now I can just keep going, no more fractions. So I'm going to expand out the brackets here. So 102x minus, let's see, what are we going to get here? It looks like 612 plus 44x plus, and what are we going to get here? Maybe 264. And then we'll distribute the 5 in on this side, so 5x squared minus 180. All right, let's do a little bit more here. What we got to do is we got to bring everything over to the right side. I like the right side because I like keeping this guy here positive. Okay, so I'm going to put my 0 here. Okay, all these guys are going to be subtracted or added over to this side. So here's what you should end up with. I got my 5x squared, then I got this 102x and 44x's. I'm going to subtract them over to the other side. So it actually turns out to be negative 146x's. Then I got to take these numbers. I'm going to add 612 to the other side, and I'm going to subtract 264. If you're careful about that, I've got down here plus 168. Okay, so let's just see if that actually does make sense. Yeah, I think it does because you're adding. So if you look at what you got here, sorry, I don't have a calculator handy, so I'm just going to kind of take a little look at it, make sure it's okay. So we would have added the 612, so it would be positive. Then we are subtracting the 264, and then we've got this negative 180 sitting there. So if I process that, that looks pretty reasonable because these guys here look like they're around 400 and something, and that's 612. So yeah, somewhere around there looks about right. Yeah, so now what I got to do is I got to try and factor this. And unfortunately, I cannot divide any numbers out. So it's kind of big and messy. So this is not going to be the funnest thing to go ahead and factor. But at least the good news is you've got a calculator to help get you through it. So I got to use magic numbers. I got to go 5 times 168 which is 840. So I need two factors of 840, and these two factors have to add up to negative 146. Now, to get through this, okay, these are big numbers, but they're not bad if you're systematic. In other words, I would start off and go, well, okay, how about 840 and 1? Is there any way I can combine these to make a 146? And the answer is no. So then I would try, well, what about 840 divided by 2? What do I got there? So, I would get 420, it looks like. Is there any way to use 2 and 420 to try to get 146? Nope, that doesn't work either. So then I just keep going. And you know what? It doesn't take you that long. You try 3, then you try 4, and eventually you're going to hit on the 2 numbers. And believe it or not, 6 is going to get you there. Because if you make them both negative, negative 140 and negative 6, guess what? We are there. So really, I was like 3 steps away from discovering this. So now let's use those magic numbers. So we'd have 5x squared, and I'm going to write the 146 using 140 and the minus 6. Okay. And then I'm going to take out the greatest common factor, which looks to be 5x. Okay, and that leaves me with an x minus, let's see here, 28, I think. And then I'm expecting to see that happen again. So x minus 28. And it's kind of thinking my way backwards. That means I would have had to have factored out negative 6. And just to check, I would go negative 6 times negative 28, which is positive 168. So here's what I got. In its factored form, I have 5x minus 6, and I have x minus 28, which leads me to 2 possible solutions here. X could be, well, let's do the easy one first. Whoops, what have I written here? X equals x. Okay, let's get rid of that. Okay, and write this a little more what we mean. X could equal 28, seems like a pretty good answer, and this would be the boat speed, so this would be kilometers per hour. Or the other possible answer, it looks like, is to try to make this 0, which if we went ahead and solved, I don't really have much room here, but let's just squeeze it in here. So I'd add over the 6 and then divide by 5. So it looks like I'd have a 1.2. Would that be reasonable, 1.2 kilometers per hour? Okay, well here's the problem with that answer. Remember our current, I deleted it all, but the current was actually 6 kilometers per hour. So when you're going with the current, that's very nice, but when you're going against the current, it's just, you're still not making progress. You're going backwards. So this doesn't really make sense. So we're going to reject that. That is a reject. So this is our answer over here. The boat speed is 28 kilometers per hour. And with that, I'm going to stop and come back with our last applications question.